So let's look at Charles' law next. Charles' law states that for a fixed amount of gas at constant pressure, the volume is proportional to the Kelvin temperature, or the absolute temperature. So in this particular case, it's directly proportional, which means if you increase one, the other increases. And so mathematically, that's volume over temperature this time equals a constant. But it also gives us V1 over T1 equals V2 over T2, which is the mathematical representation of Charles' law. So in Charles' law, if we start out with 1 liter of volume at a temperature of 200 Kelvin, if we increase that temperature, we double it to 400 Kelvin, we are also going to increase our volume to 2 liters. And so again, you see this constant relationship between the two conditions. If you change one, the other has to adjust so that you end up with the same number, this constant number. And so a great example of Charles' law is basically how you get some atmospheric changes. If you have the same number of air molecules and they are being cooled over here in the ocean, they come across the land, and that's going to cause them to warm because it's warmer on land than it is in the sea. If you've ever experienced that, you know what I'm talking about. And so when this cool air comes across land, the temperature increases, and when the temperature increases, that air is going to expand, or the volume will also increase. And when it increases the volume, you've got the same number of molecules. They're going to be more spread out, as you can see the difference between this and this, cooler or closer together, and then the more spread out as the warm air as the air is warmed. Then Charles' law tells us that the volume is going to increase, which is going to make them less dense than they were before. And since it's less dense, your warm air is going to rise into the atmosphere. So that's a direct representation of Charles' law.